Hello YouTube. Today I'm going to be going over one of the best power sources in all of Tekkit Classic. Right here we have a nuclear reactor. This nuclear reactor is, well, crap. As you can see, it's on fire. The reason for that, probably because it's over 9,000. Yeah, internet reference. Dragon Ball Z reference, excuse me. This reactor is, boring, has no special features whatsoever, and is overheating on fire. That's because it's crap. Now, today I'm going to show you how to make a good reactor. One that will never overheat, will provide you with a tremendous amount of power, and will generally all around be awesome. So let's get started. These are two different versions of my reactor. I have made each of these with some help, the help of some tutorials I found online and some information about the reactors themselves that helped me to build these. The main thing about my design is it's small. If you notice, its footprint is... My mouse is glitching on me, excuse me. The footprint is 3 by 3 by 4. And that's about as small as I think you could ever get this reactor, just because of the way the cooling system works. There's really not a lot of space you could stuff anything else in there, and then you need a high voltage transformer to lower the voltage. I mean, or you could pump it out with a high voltage wire, but it seems kind of stupid to me. And then it has an MFSU to shut off the reactor when it overheats, or when it fills up, a thermal monitor to turn off the reactor if it overheats, and a cooling system. And this is all self-contained and completely self-sufficient. You don't have to touch this at all. Now, on the Tekkit wiki, there are 5 different classifications for reactors. I'll go ahead and see if I can pull that up. Find it. There we go. There are 5 different classifications for reactors. There is the Mark 1, generate no excess heat, and and they're completely safe for continuous use as long as you supply uranium. Then there's Mark 2, designed to have a small amount of excess heat, so you have to shut them off eventually so they can cool down. Mark 3, generate a lot of heat, but they have to be able to run at least 10% of a cycle, 16 minutes and 14 seconds, before reaching critical heat or losing any components. Then you have Mark 4, run at least 10% of a cycle, just like the Mark 3's. Differences being the Mark 4 is allowed to lose components to overheating, and that must be replaced before the reactor goes critical. Mark 5s cannot run without needing a cooldown period. Having great redstone timer skills is recommended for this, or it will cause a meltdown. If you have anything but a Mark 1 reactor, your reactor's, either crap or a breeder reactor. I had tried to build a breeder reactor by essentially building a Mark 5 reactor. I think I'm going to go back and I'll probably make a tutorial for how to make a proper breeder reactor too, because I learned some new stuff to use to build a better reactor. Namely, these parts right here, which are reactor heat controls. Those are the main component of this one, which allows us to not have any ice in the reactor chamber itself, to boost the power just that little bit more. But this reactor is all you would really ever need. This entire reactor is self-contained. I'll go ahead and replace the MFSU so that you can see the power output on this thing. It is a tremendous amount of power. It's all you would really ever need, and building anything above and beyond is really just a personal choice and, kind of showing off. It really isn't gaining you all that much power-wise. See, I can generate 2,032 EU with this. I think it's more about like 2,048, something like that. It bounced up and down a little bit. But this reactor generates more than enough power. I've used this reactor to power 2-3 quarries, a force field, and all of my mechanical equipment in my factory all at once, and it has pulled through all of that without any problems whatsoever. So this thing is just a beast. There's no reason you would ever really need more than this unless you were trying to power an entire Minecraft city. That being said, I went ahead and made this. This is using some of my new knowledge on the reactors, namely these devices, as I said before, the reactor heat controls. And for the reactor heat controls, you had to add a bunch more crap. You have to add this force field, MFS reactor containment field, the EU injector, and a MFS generator core. You have to have these, or the reactor heat controls won't work. It's really irritating. If I didn't have to have these, I could build this a lot better and have a lot more, better flow of electricity through here. I actually had to move all of this. I moved this reactor containment field projector down from this top block, which extended it up another block, or 2 blocks actually, because I had to have a lever on top of it. So it was all the way up here before, but now I cut it all the way back down to the same size footprint as this one. And I know it looks a lot bigger, and that's probably also because of these plates sticking out the side. These plates are not necessary. They're just there so that I can access the components once you turn on the force field. See, I can still reach inside and touch things. If I didn't have those plates there, I wouldn't be able to do that. But yeah, this reactor is still the same footprint as the other one. It looks a lot bigger, but if you look up here, see, there's 1, 2, 3 blocks by 3 blocks, and then the whole reactor is 4 blocks high. So it's the same footprint. As I said, I just put these there so I could access the stuff while I was working on it. And you can... Wow, this is really glitching out on me. Fraps isn't liking me. You can put blocks around it normally. I had a problem... well, I've tried to film this video about 3 times now. I had a problem where it would break the blocks that I put down. So we'll go ahead and try it again. Yeah, see, it's not tearing it up now. The force field would smash up the blocks when I... Damn fraps. The force field would smash up the blocks I put down before. The way I solved that was you just break this. You break the containment field projector, and you put it back down, and it should solve your problems. You will have to put the card back in there, the link card. Jesus. This is just blowing up in my face. Come on. But it does work. You can get it to work properly. Anyway, I'll go ahead and show you how to make these, and you can make them yourself. Go ahead and start with this one. First, let me explain a little bit about this. In here, you have your self-contained cooling system, all powered by ice. Ice, a filter, a timer. You're going to need an energy collector and the energy condenser. And that makes up your cooling system. Your cooling system basically, come on, just puts ice in here, and the ice will keep everything nice and cool. When you're working on it, I put a lever right here just so you can turn off the system, because once the uranium in here depletes, it breaks, and then that hole that's left behind, it fills up with ice. If you see, actually I took that out and the ice immediately started flowing up there. So what happens is all these cells just disappear out of here, and then everything fills with ice, which is irritating if you're going to try and refill this. So what you can do is don't waste your time trying to refill it with it on. Just turn off the cooling system and then refill it. It will save you a lot of time. This reactor, I guess I didn't show you the output. I'll show you the power output of that one in a second, I think. I think I probably did show it. This one is all you'll ever need for reactor-wise. You also have a dimensional anchor up here. You can use a world anchor, You can use a world anchor or a dimensional anchor, and I think you could probably use a teleport tether too. I think the teleport tether was a little less material intensive. Yeah, see, this just uses iron ingots and a lapis, and that will generate you 4 teleport tethers. So as long as you can use those, I haven't personally tried those. Those are better than resource-wise than the world anchor, which uses obsidian, a bunch of diamonds, and gold. My personal favorite is the dimensional anchor because it's just a lot better built. You get a block of iron and 4 gold, and with this one you can then adjust the size of the this is the chunk load. The size of the chunk it loads. So if I go in here, I can expand this 9 by 9, and if I reset this, you'll see this massive chunk, this massive red square. That's the chunk that it's loading. So if you wanted to build some ridiculously huge reactor facility, you could do all of that with just one of these devices as opposed to one of those per chunk. And this is a little less resource intensive than the world anchor, so that's one of the reasons I like this one. Let me figure out the rain. Now, this one, I'll go ahead and show you how to make it. It's very simple. You would have to be kind of stupid to screw it up. Let's go with filter. You put your filter down. This is going to be your starting component. So just start with a filter. Then you're going to need an energy condenser, which is really resource intensive, but you're only going to need one of them. One per reactor though, so let's see what else. And then you're going to need an energy collector. I don't know if you can use a Mark 1 or if you have to use a Mark 2. You'll notice the EMC difference, so I would definitely want to use a Mark 1 if I could. Let's go ahead and try that actually. I hope this doesn't blow up on me. Well, actually it'll just overheat. But and then put a glowstone on top, because the glowstone will keep it powered even when it's kind of dark, and the glowstone is the brightest thing you can get. So the torch has a brightness of 14, I believe, and the glowstone has a brightness of 15, which is the brightest thing in Minecraft, other than like the sun. So the sun would be brightness 15, and the glowstone would be brightness 15 as well. I believe I have that correct. So anyway, that will give you everything you need. Ice-wise, or energy-wise. You go in here, grab a block of ice, throw a block of ice in here. That will go ahead and start generating you ice. Now, little pro tip. Put a stack of 64 ice into your filter. And the reason for that is now it will only filter out stacks of 64. So when you hook up your timer, we'll go ahead and put the pneumatic pipes in here. When you hook up your timer, it will only take out stacks of 64. So, as opposed to leaving this empty, it would take out one block of ice at a time. Putting a stack in there will take out a stack of ice every time. So you won't have to. It will go much faster and fill up the reactor much faster than if you just put one. And let's go ahead and grab our reactor components. And we'll put down one there. One there. And break that. And what you're going to want to do, best thing to do is take a lever while you're working on this thing, so you don't make a big mess. Throw a lever down and flip it on to kill the timer. And I actually leave that lever there for my design because that way, once the uranium depletes, instead of trying to fight with the cooling system, I just turn off the cooling system, wait for any excess ice to work its way out of the system, and refill it. It will then either, if the MFSU is full, it will be off the whole time, or if it overheats, it will be shut off by this. Or you could go ahead and throw a lever on there and shut it off manually, but I'm lazy and my thing's usually full. So I just fill it with uranium and then flip it back on so the cooling system comes back on. Now, go ahead and throw down your chambers. And this is, yeah, it's off now. Go ahead and throw down all your chambers. Stop lagging on me. Now, this reactor produces 2050 EU. And if you know your wires, you'll know that the only thing capable of handling that is the HV wire. And the 4 times insulated HV wire, or I think you can just use HV cable, regular HV cable. Well, the problem with that is it's massive, it takes up most of the block, and it looks hideous. And you really don't want to take up any more space than you need to. So just throw down a HV transformer. The HV transformer will lower the voltage, or the EU packet size, from the high voltage of 2050 down to 512, which can be handled by the MFSU, which we're going to be using in a second. Now we're going to go ahead and dump in our MFSU. Wow, everything's really lagging. Dump in our MFSU right there. Now, the problem with putting it like this, the pipe immediately connected to it, and it's going to dump ice into here. So what you want to do is go and grab a cover. I usually just use stone covers. You can use whatever you want. Whoops. We need that. And that's going to connect like that. And put a second one on top, and I'll show you. You'll see why in a second if you don't already know. Grab our red alloy wire. And the red alloy wire is going to go on top of here, up here, and to the reactor. Now, click this once, and you'll notice the emit if full. That means that as soon as this fills up, it will emit a redstone signal, and it will turn off the reactor. So the reactor won't even be powered anymore. It will shut off. You won't be using any fuel. You won't be wasting anything. And that's honestly the best way to do it, because you really don't want to waste that uranium. Because it is pretty hard to come by, and you just don't want to waste power when you don't need to. Just like you wouldn't leave your coal generators running ad nauseum if you, well, I think those automatically turn off, but that's not the point. Just don't waste resources is the main idea. Thermal monitor. Throw your thermal monitor up there, and then we're going to need our dimensional anchor. Dimensional anchor goes right on top. Alright, there. Whoops, wrong thing. Dimensional anchor, and then we'll throw on our alloy wire, and we'll turn this up to 5,000. I like 5,000 because it's just a nice number. Now what you can do is you can throw a block of stone right there. Come on. Throw a block of stone right here and put a howler alarm on it, which will go off if this overheats. The problem with that is if you have this lever on, it will also go off and make a hideous noise until you turn the cooling system back on, which may or may not be something you would like, just so that you have that warning if it's off. But it is very loud and very irritating if you have it on. So I generally like to keep it off if I don't need it. And you really don't need it. You could also put it up here, but it would go off as soon as the MFSU fills, which is also something you don't want. Let's see. The only thing left is to fill this with uranium, so I'll go ahead and fill this up and let you look at it. And it's probably going to overheat. I think it's, yeah, it's already running. You can see it's smoking out of the edge of the, over the edge of the thing. the window. Yeah, I see the smoke and the window's turned red on the thermometer. Alright, so that's full now. Oh, wait, hang on, we didn't even want that full. We want it like this. Leave this space open, and then turn on your cooler. And that will fill up with ice. Alright, as soon as that fills up completely, then the reactor will be completely self-sufficient and will run automatically with zero interaction from you until it runs out of, fuel. Okay, and you're done. That's it. Now, it is a little resource intensive just because your nuclear reactors always are, and these parts are a little expensive. Go ahead and check to make sure this is actually keeping up with everything. So yeah, see, it's still producing. It's not running down, so we're good as long as it's going up and not going down. We're good because this is going to constantly be pulling material. So as long as this is going up in here, you're good. So this one, that's done. And as you can see in here, it's powering up pretty quickly. And this is getting the full power from here. One thing to note, I had tried running this cable this direction. The problem with doing that is it will hit the transformer, and the transformer blows up when this thing fills up. So don't do that. I did that so that I could put the howler alarm right up here, but that blew up my transformer, and that was kind of a fail. So just leave it like that if you want. You can play around with it and see if you can get the howler alarm working, or you can just not give a crap like me. Now, let's focus on this one. This one is the Mondo reactor. You really don't need this. This is just too much power. It's too much parts, too many everything. I mean, let's see what the heat controllers use. It's in cheat mode. Yeah, you see this uses an advanced machine block, integrated heat dispensers, chests, and just, it uses way too much stuff. And then you need EU injector. And you're going to need an EU injector, you're going to need a generator core. It's not up here. Where is it? Yeah, you see, it just uses so much stuff, and you're not getting that much more power out of it. So if that extra 350 EU really means that much to you, by all means, go ahead and build this. But if not, you're just setting yourself up for, irritation, because this uses so much extra materials, so many more parts. This has to be a Mark III energy collector, I believe. That's what I used on here, and that just it's just, look at this, 710,665 EU for that one versus, let's see, this one's 82,953. So it's just so much more expensive to build this thing, and you're only getting 350 EU out of it. Just build another one. You'll have double the power that way. So I built it just as a proof of concept and just because I could, and it's creative mode and who cares. But unless you really need that extra power, it's not really worth it in my opinion. To build this, it's pretty much the same as the other one. All the main parts are the same. You're just going to need to channel some things differently. That doesn't need to be there. You just need to pipe some things around differently than you would in the other one. But the main parts are the same. We're going to go ahead and grab, empty everything, and grab our filters. We need, once again, the filter. Dump this right here, give us some space. And you're done with that. You need energy collector, or condenser. Energy condenser. And put it down this way. And you're going to need Mark III. Come on. There we go. Finally, my computer's being retarded today. Mark III and a glowstone. One glowstone to put on top. Alright. Now we've got that done. Next, we're going to need our reactors. Now, you can build this from the bottom up. Like, everything. Like, literally, you can go ahead and put in the reactor core stuff and just start from the bottom up. Or you can, you know, build it the same way I'm going to. It doesn't really matter. It's not going to make it any easier or more difficult. Reactor chambers, reactor core. Plop a reactor core on top. And reactor core on top of that. Delete that one. And put these around. Stop walking. My computer hates me. Put that like that. Now you have your reactor itself. This is the chamber and everything. Now go ahead and grab some pneumatic piping. Should we do that? Yeah, why not? Grab the pneumatic piping. Again, it doesn't really matter what order you build this in. Just as long as everything comes out correctly. And one up like that. And let's get your heat managey things. Dump one there. Dump one there. What do they call these? Reactor heat controls. Turn these on to cooler. If you don't, it won't work. Stop raining. Turn those on to cooler. And if you don't turn them on to cooler, it won't work. Now to fill up our system, we're going to get a block of ice. Pick it up. And throw the block of ice into our condenser. And again, as I said before, same thing. Take a stack of 64, put it in the filter. It'll save you a lot of headache because it will go much faster. You won't have to worry about the thing being slow. Go ahead and grab a timer. And on this one, you don't have to worry about switching off the cooling system at all because the cooling system is isolated from the reactor itself. So you're never going to get ice into the reactor unless you build something wrong. And this one, I like to put it a lot slower, or a lot faster, excuse me, just because this thing is pulling such a tremendous amount of heat, or making such a tremendous amount of heat. And you don't want to screw around with this thing. This thing is going to be completely full of uranium. That is not something to screw around with. This thing would obliterate any little fortress you have or whatever. It will not leave anything standing if it blows up. I made that mistake once. Luckily, I had my world backed up, so I just went back to that. Because I literally obliterated everything from several hundred. I had a tiny little reactor. I think it was only just one, just the main chamber. And it was a good 100 blocks away, if not more. And I was in my factory, and there was just an explosion and everything was gone. So it said you died, and you know, at that point I reset everything. And not there, the transformer goes up here. You have to be careful with these. But if you build it right, like I'm showing you, you'll never have a problem with it. It's very safe and stable. That's the whole reason, the whole idea behind my design is it's very stable, and you don't have to touch it. You don't have to worry about overheating. You don't have to worry about anything like that because it's already managing itself. Now, for these, what do you call them? The reactor heat controls. Yeah, make sure they're on cooler. And they have to have. You must have the reactor containment field. If you don't have the reactor containment field, it won't work. It's really stupid that way, but you have to have the containment field. So we got the containment field in. To turn the containment field on and off, I use wireless redstone because the levers break. And you want to be able to shut it on and off anyway. So this is one of your best options. Go ahead and set this on 2 because the other one's 1. And the same thing to turn on and off the reactor, because the whole thing will be inside of a force field. So it's best to use something wireless. Set this on 2 and this one on 20. Now we can control our reactor. Now we're going to grab an MFSU. Plop that down here. And as you noticed, it went and threw ice into here. You don't want that, so what you're going to do is go and grab a cover. Go down 1. Grab a cover. Throw a cover on there. And it will block the ice from getting in there. I wish you could do this with the wires. That would be so helpful. I could have made the reactors so much easier. But how am I spelling so wrong? Glass fiber. It would have been much easier to do this if I could do that, but it doesn't work like that. It's sad. Now up on top, your reactor generator core, your generator core, that is not on. So in order to activate that, you need a redstone torch and some red alloy. Throw the red alloy on top and the redstone torch on top of here. That'll turn that on without affecting the reactor. So that leaves that on. Your reactor core needs to be linked to the top, so you need to go ahead and grab a card. Yeah, card works. Grab a card, throw the card in the top, so it gives it a frequency, and throw that in the bottom. That'll go ahead and link these two together. A little force field tutorial for you. And those two are now linked so that you can generate your force field. Unfortunately, I can't show you that yet because it's not. The reactor isn't powering the force field yet. There's no fuel in it. Come on. Either right direction. There we go. Alright, so what else? Am I missing anything? Yeah, the dimensional anchor. Dimensional anchor and our safety feature. Yes, the two important things. If I haven't explained the dimensional anchor again already, I'll go ahead and explain it again. The dimensional anchor is extremely important. The dimensional anchor, basically what will happen with these reactors, and it will happen with any of them, so keep that in mind. It's not something you can leave out of your design ever. The dimensional anchor is essentially what's keeping this reactor functioning properly. If you leave the area, if you go doo-doo-doo and run off into the wilderness and leave your reactors behind, the block that they're in will unload from the system. So the system won't process the information that's going on in this block, like there will be no animals in here and that kind of stuff. So stuff like this timer and this filter stop working. Unfortunately though, the reactor keeps working. So the reactor will continue to heat up as you leave the area. So the filter and the timer will sit here and shut off, but the reactor will continue to heat up and to produce electricity. So it will overheat, and I don't know if it will explode, but I think there's a decent chance that it will. It all depends on if the I don't know if the thermometer keeps working once the block's unloaded. So the thermometer would if the thermometer isn't working once you leave the block, it would definitely explode, because the thermometer is the only thing standing between your reactor overheating and it, completely blowing up. So you have to have the thermometer. The thermometer is one of the most important parts, and you have to make sure it's connected properly so that it will actually shut off the reactor. You can't just slap one on the side and have it work. It will not turn off the reactor if you just slap one on the side, like so. If you just smack it on there like that, it won't do anything. That will do absolutely nothing, and your reactor will blow up, and you will feel stupid. So just make sure you have a cable or something like that to link it on there, just to make 100% certain that it's connected properly. And I think that's actually it for this reactor. Yeah, it's done. The reason I put these plates on here is so that I could access the parts of the reactor once the force field's on. The only thing left to do now is actually fill the reactor with fuel. So we'll go ahead and fill that up. And you hear the reactor turn on in the background. And it will very quickly overheat, as you can see. But the thermometer went and turned it off for me so that it won't go over 5,000 degrees. That way you don't have to worry about it blowing up in your face or something. Just make sure to set your temperature low enough that it won't blow up. Now that we've got the reactor on, you go ahead and flip this switch and you get your force field. And now you'll see it will cool down and start working, because the heat, whatever the heck they're called, the reactor heat controls, those do not work unless you have the force field up. It's really stupid, but that's how they work, so just have to work with it. And I had a problem. You see all the ice shuts off and it immediately overheats as soon as I turn off the force field. I had a problem where you can put blocks around here, and it will just not have the force field in that spot. I had a problem where when I put the blocks down and turned on the force field again, the block would explode and break. The way I found to fix that is just to break the core right there, the actual reactor chamber projector. If you break that and put your turn off the force field, break that, and then put down your blocks and put it back, and then put down your blocks or whatever, and then turn the field back on, it should allow the blocks to stay there. You will have to put the card back in there, though. If you break the thing, the old card will fall out of it. But that's the one way I found to fix it. If not, just dismantle the whole force field system and put the whole thing back together. It's only the 3 blocks right here and the redstone on top. And then you have to get the card, of course. But for that, it's not too much work. You can do it pretty easily. One thing to note, though, I didn't realize this before, I don't think. Yeah, if you look at this, this will go down. I hadn't mentioned this the last time I tried to record the video. I'm glad I noticed it. The amount of force power that's available will go down if your reactor is off, which, if I get this thing designed the way I would like it, it will automatically shut off when the MFSU fills up. If not, it will just continue to run. That's one of the reasons I don't like this particular design, because I can't get it to shut off at the moment. I have to figure out a way to get the redstone wire to the reactor, preferably without adding any more spaces. I mean, I could just run it up the side, I suppose, but I don't really want to fill in those extra spaces. I'd rather leave it as the size it is and let you just put blocks around it like this, and you could just stick it into the wall. Sorry, my phone's ringing right now. Anyway, I think I'll call it a day. If anybody has any questions or suggestions or anything, let me know. If you need any help building the reactor, have any problems, send me a message, take some pictures of it, some screenshots, send them to me, and I'll take a look at it and see if I can duplicate it and figure out what your problem is, I guess. I mean, maybe not. It depends on how many people send me random stuff like that. But, you know, I'm more than happy to help if I can. If you have any suggestions, I'm always looking for a way to improve these reactors. I just built this original design off of somebody had a tutorial on how to build the reactor like this, but they did not have it this compact. I built this thing. I wanted to squeeze it into the smallest possible space because they had like a whole block filled with this reactor almost, or a whole chunk. So I figured, you know, that's absurd. I could squeeze the whole thing into a tiny little cube. So that's what I did with these. If you have any suggestions, any observations to make, like, hey, you could just run the wire like that, or something like that, you know, I would love to listen to it. I really want to go ahead and implement the auto shut-off once the MFSU fills, but I think it will require some major shifting of the parts in here. I might have to move, like, the transformer up to the top or something and have one below it, or something like that. I don't know at the moment. I'll figure it out. I'm sure there's got to be a way to squeeze some space in there. Okay, hello again. The reactor not automatically shutting off thing was just driving me nuts. So I went ahead and figured out how to make it automatically shut off. There's a little bit of a design change overall, so I figured I'd go ahead and explain a little bit of that. First of all, what you'll notice is I moved the thermometer to the back, and the on-off mechanism is moved. This is moved here from back there. The energy collectors and the glowstone have been moved. This is the new model, by the way. The energy collectors and the glowstone have been moved, and the energy condenser and filter and timer and the piping have been changed. So the energy collector and the glowstone are here. The timer is on the inside, and it has to be facing, if you can see it, it has to be facing that way where it will start flipping on and off the force field. So it's best to lay it down from the back by breaking out the energy collector and placing it like that. Got plenty of ice. You have the filter right here, and the filter feeds ice. This has been moved from right here to up here. The alarm, the thermometer is right here and activates it right over here. MFSU is still in the same spot. That's still in the same spot. Those are still in the same spot. But now I put a glass plate here just so you could see it. You feed the wire down like this. Up the side and there, because I couldn't put a glass or a plate touching in the thermometer spot, and it won't let you run the wire up that obviously. So it has to run like that. Anyway, I just figured I'd make this little extra bit at the end to show you the new modifications I made so that you can make this reactor and have it work to its full potential. Now it will automatically shut off once it's done charging. I should probably make that so I can actually reach it. Let's see, one right here. Do. That should kill most of the force field. Alright, and now I can turn that back on. And now you can see I can access everything. It's turned off the force field, or the reactor, because it's already at full power. So let's get glass. And MFSU. Oh, let's try turning off the force field first. Oh, that's in its block. That's why. Okay. That makes sense. And you see now the reactor is turning on, and it's flipping on and off because it's going between, you know, full and off. As soon as this fills up, it'll shut the reactor back off again. I just thought I'd show you those modifications. I think I'm gonna put this up as like a second video, just so the other one isn't, you know, any longer than it was, because that video is way too long. Anyway, that's it. Hope this helped you guys.